Okay, welcome to the first lesson, which is going to be about chapter 7 of Pure, which is it's called Trigonometry and Modelling. So this is the first chapter, maybe not the first, but yeah, probably. It's the first chapter I would say that's really quite difficult of Year 13 Pure, okay? So things are starting to get a fair bit more difficult here, and you will need to revisit things and do lots of questions and all that sort of stuff, okay? Don't be deceived by the fact that there doesn't seem to be many sections here. This is actually quite a long chapter, and this is the last time really that you'll be dealing with trigonometry. So a lot of the harder trigonometry ideas are in this chapter. So we start off with something called the addition formulae. Okay, these are some rules about sine, cos, and tan when you have two different angles. So this is angle A and this is angle B. And if you wanted to find out what the value was when you added the angles and then you took sine, well, it's the same as this over here. So it's the same as sine A multiplied by cos of angle B plus cos of angle A times sine of angle B, and so on and so on. You cannot just sort of expand them or something like that. This isn't algebra. Sine is a function, cos is a function, tan is a function. Okay, these are inputs. So this is a rule about adding or subtracting inputs and it being the same as these values here. Now, why would you want this? Well, sometimes you won't know what this value is, but you will have these pieces here, for example. So you can use those to find this thing out here. Or perhaps the other way around. And there's other identities that are built off these, like the double angle identity and stuff. So they're very, very useful. Okay, they are in the formula booklet, but I would question your ambition to get a good grade, really, if you were like, I'm not going to learn them in the formula booklet. Because the problem is, in difficult questions, you need to recognize it's all about seeing the patterns and looking out for them. Okay, for example, you might have something in this format and you might need to know that you have to move backwards. And the formula booklet doesn't really help you do that. All the formula booklet does is check your accuracy as you're doing those. Okay. And in terms of proofs, you don't actually need to know the proofs of these. The only sort of exception to that is you need to know how to use these to get this one. Okay, so that's the only proof, and you'll see that in a moment, that you really need to be able to show is that one there. Why can you not just do this? Well, we talked about this. This is not, this is not algebra. You cannot just expand them. If you don't believe me, try making them both 45, for example. And you will see that sine of 90 is 1, is not equal to these added to each other. This will be root 2. Okay, so 1 is not equal to root 2. It doesn't work. Here's probably a good time for you to stop and to try and remember them. And just to show you that, you do need to know them. This is sine A cos B plus cos A sine B. Okay, why do I know that? I know that because we have to deal with this quite a lot. So you will need to know that as well. Yeah. Notice positives match positives, negatives match negatives for sine. You have sine of one, cos of the other. Sine of the other, cos of the first, or however you prefer to learn it. You see all 4 different parts. For cos has this interesting idea that cos is always cos, sine, sine. So you can't really mess that up because multiplication, you can change the order, can't you? But the sign changes. That's the only thing really to watch out for. So the next one again is cos, but because it's minus, you have a different sign, so it'll be plus sine, sine. And tan, well, tan is quite different. Tan, you can think of the top as like the sum over 1 minus the product. Yeah, we'll look at how to get that in just a moment. So starting from the formula for sine of a plus b and cos of a plus b, prove that tan of a plus b is equal to all this here. So I'm going to reveal this one and just talk through this with you because this is not obvious. You probably haven't done a division like this before. So it probably won't surprise you that the first part, you think of sine over cos as tan, right? So you write out the sine addition rule and you write out the cos addition rule. And that's your first 2 marks in this old spec question. Well, how do you get from that to that? So this is a good time to talk about a trick in maths for problem solving. What do you have? What do you need? So start with this top part here, for example. It says sine A cos B, and you want to end up with tan A. So how's that going to happen? Well, the cos B needs to disappear. So when I say disappear, really, I mean you need to divide by it. Sine becomes tan, so you need to divide also by A, sine A. So sine A cos A. Yeah. So if that first term were divided by this, that would work, wouldn't it? But there's an even easier way to see it. Look at this one here in the bottom left. It turns from cos A cos B into 1. Well, it's that division again, isn't it? That's what will make it work. So what you actually do, I've seen it written this way many times before. Let me just write out the fraction a little bit bigger. And I'm deliberately going to leave loads of space underneath. So cos A cos B minus sine A sine B. What you actually do is you divide through. So the same as like if you were multiplying by a number by 2 from some fraction, I don't know, say A plus 5 over B minus 8. We talk about multiply everything by 2. You kind of divide everything, every term by the same thing here. So you divide it by cos A cos B. You divide this by cos A cos B. And again, cos A cos B. And the last one, cos A cos B. And what happens is you get loads of cancelling out, things turning into tan. What have we got? Cancelling out, turning into tan, completely cancelling out, turning into 1. And this one here, well, turning into a tan and a tan again. And that's that one there. So it's a good trick to be aware of, not just for this particular proof, but sometimes in some of the harder questions, dividing every term through enables you to go from what you have to what they have, which is not always obvious. Okay, so what do you have? What do they have? And how can you multiply everything, or how can you divide every term in a fraction through to make it look the same is a good skill. What have we got here? So we've got sine and cos, and it says it wants tan x and tan y. So I'm going to have things here about sine x and cos x and sine y and cos y and cos x and cos y. Well, how will I get these? This is going to be by dividing, isn't it? It's going to be dividing by maybe like we've just seen, maybe some sort of like cos x, cos y. So let's investigate. Well, the first thing we do is we use the rule. So that's 2 multiplied by sine x plus y. So I'm going to put the whole addition rule that you just saw earlier here, and then I'm going to make sure I multiply it by 2. So sine of A plus B is sine of one, cos of the other. And then the way I like to remember it is like, well, what have you not done yet? You haven't done the sine y, and you haven't done the cos x. So that must be what it is. For this one over here, equals 3. Well, for cos, I'll do the same thing again here. I'm going to put the rule in. So it's cos, so cos x, cos y. Opposite sign is plus, sine x, sine y. Okay. You could then multiply out that 2 and that 3. Yeah. Then I've got sine x cos y, sine y cos x. I've got sort of a situation that's a little bit similar to before. So sine x cos y. What would be really good to divide that by? Cos x cos y would be quite good, wouldn't it? Because cos x would turn this into tan x, cos y would disappear. What about this one here? So if I divided by cos x, that would disappear. That would become tan. So I'm just going to reveal this one for you now. So you end up with this line here, and then you sort of work out that, oh yeah, dividing by that thing sort of seems to work, doesn't it? And it gives you this, which can be manipulated further. Okay. So you should be able to use the formula. The same for maybe with negatives instead of positives. You should be able to have a quick go at that one and see if that one works. We also need to be able to recognize the form and go backwards. For example, if I call 70x and 20y, well, that's also x and that's y. Can you see I've got cos x, cos y, plus sine x, sine y. That fits the pattern. The pattern backwards, cos, cos, sine, sine. This is cos, and the signs are opposite, x minus y. Okay, you need to be able to recognize it backwards. That's the challenge. Okay, and yes, it does get asked as a question, usually more with sine double angle than cos, but it could be cos as well. Just noticed we actually should write the 70 back, so that's 70 minus 20. In other words, it's cos of 50, isn't it? Because 70 minus 20. Okay, so that takes you to exercise 7a. I've left this here as a challenge, okay? So A and B, putting them together, you can use this as to sort of help you develop a geometric proof for the rules, but that's very much a challenge and it's not in the specification. So you should now be able to have a go at 7a, and please make sure that you really have kind of got those rules committed to memory and that you can recognize them before the next video.